And we're live. Hi, I'm Lucie deLaBruere, and I welcome you to tonight's Hangout, which is a short presentation on creating with code using a Chromebook. So this presentation is created as part of my Create with Chrome class at Marlborough Graduate School, and we have some students here from that grad class, along with some speakers who I have met who are doing some wonderful things using Chromebooks to create with code. And since this is Hour of Code Week, we thought we would schedule this presentation or speaking series during that time. First of all, I'd like to welcome my students from the graduate class, Nicholas and Susan and Jessica and James. Welcome, everyone.
Thank you.
And next, I'd like to welcome two of my colleagues, Jill Dawson. Hi. And Leah Joly. I'll let Jill introduce herself real briefly.
Hi, I'm Jill Dawson. James, I recognize you, and Jessica, I recognize you. Hi. I'm not teaching under a contract, but I'm an artist, and I make things with code. And so Lucie invited me to come talk with you, and I'm happy to be here and hear any questions you might have.
Great. And Leah?
I'm Leah Joly, and I teach design technology at Williston Central School, and I primarily teach middle school 5th through 8th grade, but also work with 3rd and 4th grade. And I've been using Chromebooks quite a bit with all of my students this year.
And I've had the opportunity to visit Leah's classroom recently, and it was amazing. So let's start tonight with talking about one of my favorite resources for using for coding on a Chromebook. And I prepared a short slideshow which I'll give you access to also that has all the resources from tonight. Let me bring that up. Whoops, I need to hit the screen share. Forgot to do that. And hit share. And let's do the present part. You've met myself, you've met Leah, and there's her contact information, her Twitter information, and Jill Dawson's Twitter information. And let's start talking a little bit about Scratch. Scratch used to be a local download, but it is now available in the cloud, Scratch 2.0, which makes it an awesome resource for using a Chromebook. It teaches students thinking routines that all coders need to have, like routines like sequencing and conditionals and looping. If Scratch students code using this, in Scratch, students use code using drag and drop, and they can easily just drag code into an interface where they control these sprites. Here you're seeing Scratch and a couple of other sprites on the screen to make digital stories, animations, games. And there's so many resources online for teaching Scratch that you can find Scratch cards, Scratch communities, Scratch lesson plans, almost anywhere online. Scratch teachers and students are constantly supporting each other. But recently, one of my favorite resources that I've discovered is the CS First, or Computer Science First, by Google. In this particular resource, it's filled with lesson plans for teachers on teaching computer science who've never taught computer science, and it uses a club method in this approach, and it uses Scratch in order to teach kids to code. If you want to try CS First, which does work on a Chromebook and uses Scratch, basically all you have to do is to go to csfirst.com. When you get there, your students can try these projects without signing in. You'll see there's a variety of projects that they can try. Or they can sign in where they'll get badges, they can save their status, they can become part of a club that you set up, or you can set up a class using this club format. When you do that, your students do not need an email address. When you set up your club, you'll get a class code. So when they go to sign up, they'll get something that looks like this. On the left-hand side, you'll see I am a student, and they skip that part, and they go right down to enter club code. Once they enter club code, it will automatically generate a username and password for them. If you're an educator, you're obviously going to sign in on the right-hand side, and you could use your Google account to sign in. But again, you can do this all without signing in. What CS First does is takes a theme-based approach to teaching students about coding. And you can do game design, social media, digital storytelling, all different types. When you first sign in, you're going to get what you see on the left-hand side here where it says create a club now. And it's going to walk you through step by step everything you need to do to be successful. They'll even ask you, do you want Google to ship you materials? You need about 3 weeks lead time for Google to do this, but if you do this ahead of time, you can ask Google to ship you your materials. They'll walk you through choosing the theme, the schedule, the materials, checking your computers, inviting some volunteers if you want, and then they'll take you to a place where all these materials are ready. You will see that they will have informational flyers that you can print out. I'm hearing a little echo, so I'm going to stop for a second and see if I can figure out where our echo is coming from, just because I don't want it to be there for the next few minutes. So I'm going back to our Hangout, and let's see if maybe if we can mute ourselves, and then we'll unmute when it's time to. Echo seems to be gone. You guys still hear it? Great. I'll just finish up. I have just a few more things to share about CS. Bless you, Susan.
Sorry.
Show this real quickly. They'll send you flyers they'll put up the promotional videos, the club plans. They'll give you certificates for your students, badges for your students, passports that you can download or write in, all the plans and contingency plans in case something goes wrong. And they'll give you solution sheets for all the answers, so you never have to feel stuck as a teacher. When you hit lesson plans, you're going to get activity by activity. There's usually 8 activities or lesson plans per theme, and they encourage you to only do one theme at a time so people are all kind of doing the same thing and supporting each other. And for each activity, when you click on the activity, they'll give you the solution sheet, example projects, an agenda timer, step by step on how to do every single lesson, including a script if you want it. And you can close the script out if you don't need it. And so I can't say enough about CS First as having given teachers everything they need to be successful in having students learn Scratch and teachers learn Scratch. I know one of the things that I did is I asked my graduate students to pretend that they were students, and I gave them a student avenue and code for CS First. Nicholas or Susan or James, do you have anything you want to comment about that experience, or Jessica? No comments.
No comments.
Okay. But all the experiences, the lessons, the materials are all there for you, and it walks you step by step. Once you get that level of confidence, one of the things that you may want to do is start to bring in physical objects or physical. Recently, I walked into Leah Joly's class and saw that students were actively engaged using a device called a Makey Makey, which I'll let her talk about, and Scratch and their Chromebooks. Leah, would you like to share a little bit about the magic that happens in your classroom?
Sure. Actually, talking about Scratch is a good segue into the big project that I've been working on with my students. I just wanted to tell you a little bit about the scenario of my job, as far as the time that I have, and kind of how it fits into my curriculum. I see all of the middle school students in my school for 6 weeks, every day for 6 weeks, and they're 40-minute sessions. So this project, I was trying to put it on paper how much time it takes. It took probably between 10 to 14 of those 40-minute sessions to complete. So that just gives you an idea of kind of what went into it. And so I'm a design technology teacher. In my classroom, I have 3D printers, I have a vinyl cutter, I have woodworking, craft items, kids bring Chromebooks. I have just lots of different materials, electronics section. I think Lucie showed a picture of my room earlier. So it's still a work in progress, changing from a more traditional program into more of a maker space right now. And I just wanted a project that would really incorporate or open up the possibilities to be able to use a lot of the tools in the classroom and would tie in a programming and coding piece to that. So I thought of using Scratch, which I think a lot of the kids are familiar with just from either Hour of Code or just dabbling in a little bit throughout the years at our school. So I introduced Scratch in one day and let them play with it, do the tutorials, kind of self-guided. I was fortunate enough in at least 1 or 2 students in every class were quite experienced, so that helped. So I really counted on them as mentors for the rest of the students in the class and for myself. I learned a lot from them. And then I also introduced the Makey Makeys, and if you're not familiar with those, they're just a small circuit board that plugs into a computer with a USB cord. They work really well with Chromebooks. They're just plug and play, and they automatically are hooked up. So I have a slideshow that I can kind of show you and then talk through how it works. But when I introduced the Makey Makeys, to make them into game controllers, they have to have some conductive materials hooked up. And I just made a list of some of the materials that we use and some of the tools that we use in the room. And we use Legos, fabric with conductive thread, Play-Doh, lots of tin foil, wood, conductive paint, regular acrylic paint, 3D printed game controllers, cardboard, pipe cleaners, everything. Really, it was very cool that some days I would just take a video of all of those things were happening at once, and so it was just very exciting to see. Most of the classes I assigned groups of 3 or 4 students to work together, and they could either all work on the game controller and all work on the programming together, or they could divide up and kind of separate the tasks. So I'm going to see if I can figure out how to do screen share. Can you guys see my screen?
Not yet. When you do screen share, does it pop up a window, or does it you have to say start? Now we can.
So now you see that. Now can you see my pictures?
Can you see your pictures? You have to just click on that screen.
I'm on that screen, so.
Or tab? Is it on a different tab?
Oh, here we go. It may not allow me access. This is new for me, so. I know Lucie has some pictures too that maybe you could open them up and I could talk as you're.
All right, I'll do that.
Them.
So you'll unshare and I will share mine. That way I'll have your pictures on.
Okay. So I don't want to. There we go.
You should be able to see that now, I think.
Let's see them. They're a little bit small.
Let me see if I can make it bigger.
Yeah.
How's that?
Okay, so you guys can see in the upper right-hand corner, those are a couple 3D printed pieces that students made. So they made a 2-player game, and the way they connected that, you can see there's lots of alligator clips involved in this project. So they're connecting those to the Makey Makey, which is in their hand. The student right below them has a Lego controller that he created with some rubber bands. It also has, the rubber bands are connected to push buttons. And that's also conductive. And then next to that, I think to the left, that's also a Lego controller. And then over to the side, to the left-hand side, I think there's some duct tape pieces coming. Actually, that doesn't even look like it's from my class. I think that might be another class that Lucie put in. And then the girls up above in the upper left-hand corner have a fabric game controller with felt and conductive thread. So those are just some examples. If you go to my blog, I have a couple different slides. Oh, there we go. Wow, that's impressive. There's another one with a piece of recycled styrofoam. The two round pieces that you can see on there are like dish scrubbies. Those are really handy for making game controllers. Kids use those a lot. Some of them even put them on their wrists because they're conductive and they could be a controller that way. But if you go to my blog, you can kind of see some more examples, and you can see some videos of the kids in action. One of the culminating, to finish up the project, they were able to present, and I know Lucie and Jill both came in to see the presentations, and it was nice for the students to get some feedback from other people outside of the school. And we also were a part of the Vermont Tech Jam, and that was really amazing for my kids to be able to show off their projects to a bigger audience. And one of the games, if anyone's familiar with the song Watch Me with the Whip-Nay dance, one of the game controllers was a large game board that sat on the floor and was hooked up to a large screen TV and was drawing crowds of, I don't know, 50 people at a time waiting in line to play at the Tech Jam, which was really, really exciting and great feedback for my students. So, and then we're setting up on Friday, I know, for some other people to come check them out, but it's great, and I get to do it every 6 weeks. I get a whole new set of games and controllers, and every time it's different, so it's been fun.
Thank you so much, Leah. Any questions for Leah from our grad students? All right, quiet group. I'll transition over to Jill. Once our students are familiar with Scratch and are able to use a Makey Makey, they might want to gravitate toward an Arduino and to work with text-based coding. And I'll let Jill talk about what that looks like.
So in the summer of 2014, the National Writing Project started creating something called the 21st Century Notebooking Project, or sometimes people refer to it as notebook hacking. And the concept behind this is that students would integrate writing or other forms of literacy and other forms of art with coding. And one of the things that they would bring in would be paper circuitry that would be controlled with small microprocessors, in particular the AT-Tiny, which is a microprocessor about the size of your thumbnail. And what I've been experimenting with, and I plan to bring this into a classroom in Colchester, is coding these tiny microprocessors with an Arduino board using CodeBender, which is a cloud-based platform that allows you to share your code with other people, and you can create your own code and share with others, or you can download and borrow other people's code. But with the idea of bringing the coding, this is just an example of a piece of artwork that I made with one of these microprocessors. You can just see the circuit, and I've been doing a lot of sugar skulls in my artwork, but the whole idea is not just to do artwork, but to actually integrate the writing process with the coding as well. So I'm partnering up with a language arts teacher at Colchester Middle School, and we plan to bring coding into the language arts classroom, to bring writing and coding together. So you can learn more about that at nextmap.org if you want to know more about the 21st Century Notebook Hacking program. And if you wanted to learn more about CodeBender, I created a screencast that's in Lucie's slide presentation that teaches exactly how a student could code the small microprocessor and put it into a project. And also on my blog, there's a lot of other information about different things that I've been doing with this small microprocessor. And I've been learning how to code. I'm getting better at it, so there's been a steep learning curve for me too, but I think it's something that's really accessible and doable for students and for teachers as well. And since this little chip, it only costs like $2 for one. It's really an inexpensive way to give students experience making with code. And a lot of people have Arduino Unos kicking around and they don't really know what to do with them. So CodeBender is a really good resource for educators with Chromebooks in their classrooms.
So do you, Jill, I know that before you discovered CodeBender, you were programming with the Arduino by just downloading the software?
Yeah, I would, before I found CodeBender, and I still sometimes use regular Arduino, the regular Arduino IDE on my PC. But you have to download a bunch of drivers, which can be really time-consuming for teachers, especially if they have a variety of different devices, or maybe if they want to teach a workshop to people who have like Macs. And if people have a bunch of different devices, that having all those drivers can be really confusing. So if you go into CodeBender and use Chrome, it's a really easy way to have everybody on the same page, and it's a collaborative environment. So that's why I think it's really, really cool. And there are other things you can do in CodeBender too. Like you can use a different type of microprocessor. Like Lucie's been using a lot of the Lily pads. Lucie and Leah, all three of us have. But you can also program these in CodeBender. So they keep adding new functionality all the time. It's really cool.
Questions for Jill?
So when you say that they're coding in their language arts class, what are they coding?
They're writing code to make the microprocessor control the function of lights that they write stories to go with. Does that make sense?
Yeah.
Okay. So one example would be students did a research project on, and it could be on of something that influenced their lives. It could be anything. Like I picked a spork, which is really silly, but the kids picked other different things, and they had to research it. They had to write about it, do an illustration, and we did paper circuitry with those pieces of writing. We haven't yet integrated the microprocessor because we're building their skills slowly, but it's just another tool to kind of bring action and into the classroom with the writing piece. And you can also animate. You can also take video footage of the animated artwork, and you can create 25-word stories. I mean, there's a lot of cool applications for this.
Great, thanks.
So tonight was going to be a short introduction to these resources, just to let you know that if your students have Chromebooks, there are some resources out there that they can use to learn to code. I hope that you'll explore the resources that we're going to put in both the show notes, the event, and that you see in the chat. Thanks so much to my grad students for coming in tonight. Thank you very much, Leah and Jill, my fellow educators, colleagues, and fellow makers, for joining us tonight and for sharing your resources and your wealth of information with everybody.
Thank you.
Happy hour of Code Week. Bye-bye.
Bye.